Wait a second. Look at this musician playing the guitar. They're moving their fingers all up and down the neck, but they're plucking the exact same string. So, how can one single guitar string make so many different notes? The string itself is the same, so what in the world is the musician changing?
Take a quick second to predict what's happening. What's the secret? Got a guess? Okay, let's dive into this explainer and find out. It turns out the musician is actually changing how fast the string vibrates. To really understand how that works, we need to remember the absolute golden rule of sound. Pitch tells us whether a sound is high or low. And the rule is super simple. Fast vibrations create a higher pitch, and slow vibrations create a lower pitch. That's literally the secret to music. Fast means high, slow means low.
Now the real question is, how can we actually make a vibration faster or slower? Well, think of it as a chain reaction. If you make physical changes to a string, you change its vibration rate, which is just how fast it moves back and forth. And when you change that rate, you completely change the pitch we hear.
There are 3 specific ways musicians change their strings to alter the pitch. They can change the string's thickness, its tension, or its vibrating length. Let's see how each of these magical changes works on stringed instruments like guitars, violins, or harps.
First up is thickness. If you look really closely at a guitar, you'll see the strings aren't all the same size. When all other conditions are equal, a thinner string vibrates faster. And remember our rule? Faster means a higher pitch. A thicker string has way more material to move, so it vibrates slower, giving us a nice, lower pitch.
Next, we have tension. Tension is just a fancy science word for how tightly a string is stretched. Musicians use those little twisting knobs at the top of a guitar or violin, called tuning pegs, to really carefully adjust this stretch.
When a musician turns those pegs, magic happens. Tightening a string makes it vibrate faster, which makes the sound higher. If they loosen the string, it slows the vibration down and the pitch gets lower. That's exactly what's happening when you see someone tuning an instrument.
So what about the musician moving their fingers up and down the fretboard? They're changing the vibrating length. Pressing a string down doesn't make the rest of the string magically disappear. It just makes the part that's free to vibrate much shorter. And a shorter vibrating length vibrates faster, creating a higher pitch.
Now stop right there, because we need to correct a huge mistake people often make. Sometimes we think that if we just pluck a string really, really hard, the pitch will automatically go up. But that is totally false. Plucking harder mainly creates a bigger vibration, which just makes a louder volume. It does not make the pitch higher. Bigger vibrations make louder sounds. Faster vibrations make higher pitches.
Okay, let's pivot to a totally new mystery. A guitar has strings, sure, but look at a wind instrument like a recorder, a flute, or panpipes. There is absolutely no string inside them. So what invisible thing is vibrating to make the sound?
The answer is air. Air is actually matter made of tiny particles, and it can vibrate. When we blow into these instruments, we create a vibrating body of air inside the tube. Scientists call this an air column.
And here's the amazing thing. The exact same rules that worked for strings work for air. A shorter air column vibrates faster, giving us a higher pitch. A longer air column vibrates slower, giving us a lower, deeper pitch. You can see this super easily on panpipes. The short tubes make the high notes, and the long tubes make the low notes.
But a recorder is just one single long tube. So how on earth does it make different notes? Well, opening and closing the finger holes on a recorder doesn't just let air leak out. It actually changes the effective length of the vibrating air column inside. Covering the holes makes the effective air column longer for a low pitch, and opening them up makes it shorter for a high pitch.
Let's put this to the test with a classic science mystery. Imagine we have identical glass bottles, but we fill them with different amounts of water. If we blow across the tops of the bottles, which one will sound higher? The one with a lot of water or the one with just a little water? To figure this out, we have to remember what's actually vibrating when we blow across the top. Spoiler alert, it isn't the water. The vibrating system is the air inside the bottle. The water's only job is to change the amount of airspace available to vibrate. More water simply means less airspace. Less water means more airspace. To solve this, we need to set up a fair scientific test. Our independent variable, the one thing we deliberately change, is the water level. Our dependent variable, the thing we're listening for to see what happens, is the pitch. And our control variables, the things we absolutely must keep exactly the same so it's fair, are the bottle size, the shape, and the way we blow across the top. Let's walk through the scientific method together. Step 1. Predict. What do you think is going to happen? Step 2. We blow gently across the top of each bottle. Step 3. We observe the pitch. Does it sound high or low? And Step 4. We make our conclusion based purely on the evidence.
And here is that conclusion. The bottle with more water has a smaller, shorter airspace. Because that air column is shorter, it vibrates faster and makes a higher pitch. The bottle with less water has a big, long airspace, so it vibrates slower and makes a lower pitch. Remember, shorter air column equals higher pitch.
But I need to issue a really critical warning right here. Blowing across the bottle is completely different from tapping it with a mallet. If you tap the bottle, you aren't vibrating the air anymore. You're actually vibrating the glass and the water together. That is a totally different vibrating system, and it'll give you a completely different pitch pattern. Always remember, in our experiment today, we are blowing to vibrate the air. We've looked at so many amazing things today. A drum, your voice, a guitar string, and the invisible air inside a recorder. They all look totally different. But I have one final challenge for you to synthesize everything we've uncovered in this explainer. What one single idea connects all of them?
Vibration. Absolutely every single sound in the universe begins with something vibrating.
And this brings us to our final, unforgettable rule of sound. If you change the vibration size, making it bigger or smaller, you change the volume, making it louder or quieter. But if you change the vibration rate, making it vibrate faster or slower, you change the pitch. Every sound begins with vibration. Change the vibration, and you can change the sound. Keep exploring, keep listening, and I'll catch you next time.